Hello and welcome to the C++11 Beginner Tutorials by Gamer2Creator. I'm Chris. Okay, so in the last lesson we talked about unique pointers. I wanted to make a few more points on unique pointer. First of all, I think I started to say that this is actually a C++14 feature that Visual Studio already supports, and I think some of the other major compilers do as well. And I'm only talking about this make unique. Unique pointer is a C++11 feature, but this particular function is a C++11 or C++14 feature that is, I think, fairly widely supported already. Now there is also a make shared, which is a C++11 feature, and that goes with a shared pointer to a foo. We have our pointer to a foo, std make shared. So I want to talk about the differences between unique pointer and shared pointer. First of all, unique pointer takes ownership of the object you passed in, and I'm going to go back to using new foo just to make it a little more clear that that is actually what's happening. And the same thing is new foo. The unique pointer is meant to uniquely represent and own dynamic memory, whereas the shared pointer is meant to have multiple copies of that pointer and count how many times it's referenced or pointed to throughout your program, and when the count of objects referring to that address reaches 0, the object is destructed. So it's sort of in a way, it's a reference counting system, but it's sort of in a way a little bit of a garbage collection technique. But it can be quite handy, because there can only be one copy of it. You can use move semantics to move it around, but there will always only be one owner. This implies shared ownership. And every time you have one of these that points to this object, you're pointing to the same object. You're sharing it. So I'm going to go ahead and make some examples. So I'm making two functions. Giving them really just kind of whatever name popped into my head at the time. It's not important. But I wanted them to have different names so that you can see in the debugger that they all point to the same exact object. So we're going to come down here, and actually, to make this easier to tell, I'm going to set this to some weird number, like that. Now we're going to look in the debugger. You can see that our unique values, width and height, are within this object under the pointer field, right there and right there. There's also a couple other datas. Let's take a look. Here you can see uses and weeks. These are the two numbers that the shared pointer uses to count how many objects are referencing this address. So we're going to jump into some func. And this object is going to be copied because it's not passed by reference. So what happens when we get to here? Okay. We have the same pointer, but we have 2 uses and 1 weeks. And main foo down here should still have, come on, there. It should jump up to 2 as well, because they're actually using the same object to count with. And then we'll make another copy here, and it should jump up to 3. As this object is referencing it now, we have 3. Okay, now we're about to jump into another function and copy it yet again. And I skipped over it. Let's do that again. Gotta click step into, step out, step into. And now we're in this function. So we've called this function, we jumped to this function, and we called this function, and we jumped into this function. We have several copies of this shared pointer, but they're all referencing this original object and this address. And they're all counted by how many we have in existence, and we have several in existence now. We can go all the way back to here and see that this object still knows about all the others by the count. There's 4 total. This one, this one, this one, and this one. 1, 2, 3, 4. But we've got to the end of our another function, and these functions are going to start returning, and these scopes are going to start ending, and we're going to go in reverse. Okay, this object is about to be destructed. We jumped up to 5, and we're going to go over. So now you'll see that we have 3, because this object and this object have destructed because this scope ended. And now this object and this object is about to be destructed, so we're going to drop down 2 more. And now we're down to 1 and 1. And when we exit this, the constructor should be, the destructor should be called. And I don't know if you saw it there, but it flashed. So that is, in essence, what a shared pointer is. It's shared amongst many instances and still guarantees that your object will be deleted when all of these shared pointers are destructed. Now, all of these objects have some stuff on them, some functionality. You got the get. The get function actually returns this pointer. So we can declare foo pointer to a foo equals unique pointer has this function as well. And you can see that this address right here that's inside of this pointer is the same as that address. We'll say 2F9A79. 2F9A79. So that is what the get function does, and that is also on unique pointer. The reset function. On a unique pointer, because it's the only object that owns that pointer, it will actually immediately destroy whatever is inside of it with a unique pointer. A shared pointer will destruct this particular shared pointer, or shouldn't say destruct, it will remove itself as a reference to the object that it was referencing. And if it's the last object that was referencing it, it will destruct it. So these two functions you'll be using quite a bit. And you can also send in with reset another pointer for it to take ownership of. So it'll destruct the one that's in it and then add this one to it. And you could also use make shared. You could make another foo if you wanted to. And I believe that that's all the main stuff that I wanted to cover. Yeah, that's all the main stuff. So as you can see, they're really not that complicated, but they do help you because I never had to directly use new or delete anywhere in my program. And when you get into a lot of different functions that can return or break in a lot of different places, having an object that will automatically call delete for you cleans up your code considerably and will make your program a lot less buggy and error prone.